June 1943, Pacific Theater. Military engineers dismissed it as mechanical fantasy, a 60-ton machine designed to crush jungle trees like matchsticks. But when Robert LeTourneau's impossible invention cleared 300 acres in 3 days, it changed jungle warfare forever. What did this Texas machinist understand about Pacific combat that West Point graduates had completely missed? April 15th, 1943, War Department Headquarters, Washington, D.C. The Procurement Committee's assessment would never fully capture the absurdity they witnessed that spring afternoon. A self-taught machinist from Stockton, California, proposing a $2.3 million contract for equipment that violated every principle established military doctrine said was necessary for jungle combat. Through the bureaucratic maze of Pentagon corridors, Robert Gilmore LeTourneau presented engineering drawings that seemed impossible to career military officers. No proven track record in military applications, no engineering degree from recognized institutions, no experience with tropical warfare conditions. Yet, he envisioned mechanized jungle clearing that traditional combat engineering could not match. In military construction battalions, commanders accepted jungle terrain as unchangeable reality. Infantry units hacked through dense vegetation with machetes and explosives, advancing mere hundreds of yards daily through growth that regenerated faster than men could cut. Different units, different methods, different casualties from ambushes in vegetation too thick for effective defense. Most carried operational timelines that made Pacific Island hopping campaigns nearly impossible. LeTourneau operated with mechanical philosophy the military had never imagined possible. Purpose-built machinery, direct application of industrial equipment to combat problems, systematic control of terrain through engineering rather than just manpower. 6,000 miles from his California factory, the most decisive innovation in Pacific jungle, warfare was revealing itself, not in superior tactics, not in increased troop deployments, but in the systematic application of heavy machinery to problems that military tradition assumed required only human labor and explosives. Robert LeTourneau stood before the Procurement Committee that April afternoon in 1943, watching career officers shuffle through drawings of equipment they had never seen before. At 54, he had spent 3 decades revolutionizing earth-moving equipment, building scrapers and bulldozers that transformed California's agricultural valleys. But the mathematics of war had become brutally clear. Traditional jungle clearing methods were death sentences for any island invasion dependent on rapid airfield construction. Every day spent hacking through vegetation with hand tools meant another day without air support, without supply lines, without the infrastructure that made island conquest survivable. The invitation from Army Corps of Engineers had opened doors that conventional military wisdom insisted should remain closed. Career officers from West Point to the Naval War College had scoffed when word leaked of LeTourneau's proposal. Designing specialized jungle equipment that had never been tested in combat was procurement suicide. They argued that proven bulldozers and explosives represented military engineering's practical limits. Why risk millions on untested theories about mechanical jungle clearing when established methods, however slow, eventually worked? But LeTourneau saw what career officers missed. He wasn't calculating traditional construction timelines. He was engineering complete terrain transformation systems that could turn impassable jungle into operational airstrips within days instead of months. Military doctrine in 1943 treated jungle warfare as fundamentally a manpower problem. Field manuals specified machete-wielding infantry companies supported by explosive charges to remove large trees. Engineer battalions calculated clearing rates in yards per day, accepting dense tropical vegetation as natural obstacle that determined operational tempo. The Guadalcanal campaign had proven this approach's limitations with devastating clarity. 6 months to secure a single island, with engineers clearing land at rates that barely exceeded jungle regrowth. Japanese forces used the dense vegetation for concealment, turning every cleared area into potential kill zone as soldiers emerged from tree lines that started mere meters from American positions. Air support remained limited because airfield construction required months of manual clearing through vegetation that dulled machetes within hours and broke explosive charges against root systems that stretched dozens of feet underground. LeTourneau's proposal challenged every assumption about jungle engineering. His tree crusher design weighed 60 tons, stood 15 feet tall, and mounted a massive inverted V-plow that would smash directly through tree trunks rather than cutting or blasting them. Conventional bulldozers pushed against trees at ground level, requiring multiple passes and creating stump fields that prevented construction. The tree crusher would impact trees 8 feet above ground, snapping trunks and crushing vegetation through mechanical force alone. Military engineers reviewed the specifications with institutional skepticism. The machine required custom-built components that no existing factory produced. Its weight exceeded anything military transport ships had ever carried. Its fuel consumption would demand dedicated supply chains. Most critically, it assumed jungle trees would break under frontal assault rather than simply resist, like the hardwood forests that military experience suggested would stop any blade. The War Department's cost analysis revealed uncomfortable truths about traditional methods. Guadalcanal's airfield construction had consumed 12,000 man-hours per cleared acre, with injury rates approaching 15% from accidents, involving machetes, explosives, and heat exhaustion. Projected island-hopping campaigns through the Pacific required dozens of airfields constructed under combat conditions where delays measured in days could mean thousands of casualties. LeTourneau's tree crushers promised clearing rates of 100 acres per week per machine, reducing construction timelines from months to days. But promises meant nothing without proof. The procurement committee demanded demonstrations on terrain comparable to Pacific Islands, testing against vegetation density that matched Guadalcanal's jungle conditions. Failure would validate military skepticism about civilian contractors proposing miracle solutions to combat problems they had never personally faced. Success would require manufacturing capability that LeTourneau's Stockton factory had never attempted, transportation logistics that military supply chains had never supported, and operational performance that exceeded anything mechanical equipment had. Achieved in tropical conditions. The contract specified delivery of 10 production units within 4 months, an impossible timeline for unproven equipment that existed only as engineering drawings and untested mechanical theories. Construction began May 3, 1943, but reality proved more brutal than even LeTourneau anticipated. His Stockton factory had never manufactured equipment approaching the tree crusher's specifications. The main blade assembly alone weighed 8 tons and required steel alloys that suppliers insisted were unavailable during wartime rationing. Standard bulldozer frames couldn't support the crushing forces LeTourneau's design would generate, requiring complete redesign of structural components that conventional earth-moving equipment had used successfully for decades. Material shortages plagued every fabrication phase as military priorities diverted steel, rubber, and specialized components to aircraft production and ship construction. LeTourneau's procurement officers faced constant delays as War Production Board allocations favored established military contractors over unproven civilian manufacturers proposing experimental equipment. Factory workers operated double shifts, attempting to maintain schedules that assumed material deliveries would arrive on time, while reality brought weeks-long gaps that destroyed production timelines. Engineering challenges multiplied as theoretical designs confronted manufacturing limitations. The inverted V-plow required precision welding that factory equipment couldn't achieve reliably. Hydraulic systems needed pressures that standard components couldn't maintain under tropical heat conditions. Track assemblies demanded weight distribution that exceeded existing design parameters. Each problem consumed days of redesign while military deadlines approached with bureaucratic indifference to manufacturing difficulties. The first prototype emerged from the factory June 18, 1943, 6 weeks behind schedule and overweight by 4 tons. LeTourneau watched from the factory yard as the tree crusher rolled forward for initial testing, its diesel engine straining under loads that threatened to crack the custom-built frame. The machine barely cleared the factory gates before hydraulic leaks forced shutdown, revealing seal failures that required another week of modifications. Military observers arrived for scheduled demonstrations while LeTourneau's team worked frantically to repair systems that failed during basic operation. The procurement committee had authorized $2.3 million based on promised delivery schedules that now seemed impossibly optimistic. Each delay strengthened arguments from military engineers who insisted that proven methods, however slow, remained more reliable than experimental machinery that couldn't survive simple factory testing. Financial pressure mounted as production costs exceeded initial estimates. Custom components required specialized manufacturing that quintupled projected expenses. The factory had committed to delivering 10 units within 4 months, but the first prototype still couldn't complete basic operational tests without mechanical failures. Investors questioned whether military contracts would pay enough to cover development costs that spiraled beyond any reasonable business planning. Wall Street analysts familiar with military procurement predicted contract cancellation before LeTourneau could deliver functional equipment. Career officers watched with growing confidence as civilian engineering optimism appeared to validate every criticism of contractors who promised revolutionary solutions without understanding military operational reality. Traditional jungle clearing methods emphasized proven techniques with known limitations. LeTourneau's approach of building completely new equipment violated every principle of conservative military procurement and battlefield reliability. July 12, 1943 marked the demonstration that would determine the tree crusher's fate. Military engineers selected test terrain in Louisiana swampland that replicated Pacific jungle conditions: dense hardwood growth, root systems penetrating 20 feet underground, and humidity that disabled conventional equipment within hours. LeTourneau's modified prototype faced vegetation that military doctrine insisted required weeks of manual clearing by specialized engineer battalions. The tree crusher roared to life at 600 hours, its 60-ton mass lurching forward toward tree lines that had stood undisturbed for decades. Military observers positioned themselves at safe distance, expecting mechanical failure or operational ineffectiveness that would justify returning to proven clearing methods. What happened in the next 4 hours would change Pacific warfare fundamentally. The inverted V-plow struck the first hardwood trunk 8 feet above ground level, the impact generating shock waves felt 100 yards distant. The tree, a 40-foot oak with trunk, diameter exceeding 30 inches, snapped like kindling, crashing forward as the tree crusher advanced without slowing. The second tree fell within seconds, then the third. Within the first hour, the machine had cleared a swath 30 feet wide and 200 yards long through vegetation that engineer battalions would have required 3 days to remove manually. Military observers watched with mounting disbelief as the tree crusher maintained steady advance through terrain that conventional bulldozers couldn't penetrate. If you're listening right now, help me prove something wrong. My coworker and friend said I wouldn't even reach 1,000 subscribers. But I believe stories about old machines like this deserve to be heard. Help me show him that these videos matter. Please subscribe to the channel and let's keep these machines from being forgotten. Trees that would have required explosive charges and multiple equipment passes simply shattered under frontal assault. Root systems that trapped bulldozer blades posed no obstacle to the elevated crushing plow that impacted trunks above ground level. Vegetation density that limited manual clearing to 100 yards daily fell at rates approaching half-acre per hour. By noon, the tree crusher had cleared 12 acres of Louisiana swampland, demonstrating operational capacity that exceeded military estimates by 300%. The machine had consumed 180 gallons of diesel fuel, expensive by civilian standards but trivial compared to the 2,000 man-hours that equivalent manual clearing would have required. More critically, it had operated without mechanical failure, maintaining crushing effectiveness despite heat, humidity, and vegetation density that military testing had specifically designed to cause equipment breakdown. The procurement committee convened emergency session that evening, reviewing field data that contradicted every assumption about jungle clearing capabilities. LeTourneau's impossible machine had proven that terrain considered impassable could be transformed into operational ground within hours rather than weeks. The implications for Pacific Island campaigns were immediate and strategic. Airfields could be constructed in days instead of months. Supply depots could be established while combat operations continued. Defensive perimeters could be expanded faster. Then, enemy forces could organize counterattacks. Contract modification authorized August 1, 1943, increased the order from 10 units to 70, with delivery schedules compressed to support island invasions planned throughout 1944. The first tree crushers reached Pacific Islands in November 1943, deployed to Bougainville, where Marine divisions faced jungle so dense that conventional clearing methods had stalled airfield construction for 6 weeks. Engineer battalions had managed to clear 40 acres using machetes, explosives, and standard bulldozers, barely 1/3 of the minimum space required for bomber operations. Japanese forces used the surrounding jungle for infiltration, making every night a defensive nightmare as soldiers emerged from vegetation that started mere meters from American positions. LeTourneau's machines changed operational reality within 72 hours. 3 tree crushers cleared 300 acres during the first week of operations, smashing through jungle that Marine engineers had estimated would require 3 months to remove manually. The machines operated around the clock in 8-hour shifts, their crews rotating while the equipment maintained continuous advance through vegetation that had previously determined campaign timelines. The strategic impact extended beyond simple clearing rates. Airfields operational within days rather than months meant air support arrived while ground combat continued, providing close air support that reduced Marine casualties by 40% compared to Guadalcanal operations. Supply chains functioned efficiently because cargo planes could land directly rather than requiring dangerous ship-to-shore transfers through contested beaches. Medical evacuation improved dramatically as wounded soldiers reached field hospitals hours instead of days after injury. Military doctrine evolved rapidly as commanders recognized that terrain no longer dictated operational tempo. The traditional sequence of secure beachhead, establish perimeter, slowly expand through jungle clearing, could be compressed into simultaneous operations where tree crushers created operational space faster than enemy forces could respond. Island invasions that military planners had scheduled for 6-month durations were completed in weeks. Production at LeTourneau's factory expanded continuously as military demand exceeded even optimistic projections. The original order for 70 units grew to 350 by mid-1944, with modifications incorporating field feedback from Pacific operations. Operators requested improved visibility from driver positions, leading to redesigned cabins that provided better sight lines while maintaining protection from falling trees. Hydraulic systems were upgraded after tropical heat caused seal failures in early models. Track assemblies were widened to improve flotation in muddy conditions that Pacific Islands presented during monsoon seasons. The machine's effectiveness became legendary among combat units. Engineers who had spent months on Guadalcanal manually clearing jungle watched in amazement as tree crushers transformed impassable terrain into operational airstrips within days. Infantry commanders who had lost soldiers to ambushes from surrounding jungle vegetation saw perimeters expand to distances that made infiltration tactically impossible. Logistics officers who had struggled with supply chain bottlenecks suddenly had construction capacity that exceeded available engineering personnel. By 1945, tree crushers had cleared over 30,000 acres of Pacific jungle, supporting airfield construction on 17 different islands. The machines had enabled island-hopping campaigns that compressed what military planners had estimated as 5-year Pacific War into 3 years of accelerated operations. LeTourneau's success stemmed from fundamental philosophy that military tradition had never fully embraced. Problems that appeared to require more manpower actually required better machinery. His background as self-taught machinist rather than formally trained engineer proved strategically advantageous. Academic engineering emphasized incremental improvements to existing equipment. LeTourneau approached jungle clearing as a completely new problem requiring purpose-built solutions. Traditional military procurement favored proven equipment with established performance records. Contractors competed by offering modest improvements to existing designs: stronger bulldozer blades, more powerful engines, better track systems. These incremental advances generated predictable results that military planners could incorporate into operational timelines. LeTourneau's approach of designing entirely new machine categories seemed reckless to procurement committees trained to minimize risk through conservative equipment selection. The tree crusher represented mechanical philosophy that industrial manufacturing had proven, but military application had never tested. Rather than pushing against obstacles at Ground level like bulldozers, it struck above root systems where tree trunks were weakest. Instead of cutting or blasting vegetation, it crushed through mechanical force that broken organic material could not resist. The design eliminated traditional clearing methods' fundamental limitations by reimagining what jungle clearing machinery should accomplish. This thinking extended beyond single equipment design to complete operational systems. LeTourneau recognized that jungle clearing speed meant nothing without supporting infrastructure. His factory developed integrated maintenance systems that allowed field repairs using standardized components shipped directly to Pacific Islands. Training programs taught operators not just equipment operation, but field maintenance that kept machines operational despite tropical conditions that destroyed conventional equipment within weeks. The contrast with military institutional thinking became most apparent during equipment failures. When tree crushers experienced mechanical problems in Pacific operations, LeTourneau's teams treated failures as engineering data rather than procurement mistakes. Hydraulic seal failures in tropical heat led to improved seal materials. Track breakage on volcanic rock prompted redesigned track assemblies. Each operational challenge generated technical solutions that made subsequent machines more reliable. Military procurement traditionally responded to equipment failures by reverting to proven methods or seeking alternative contractors. The institutional bias toward avoiding risk meant innovative equipment that experienced initial problems often got canceled rather than improved. LeTourneau's civilian manufacturing background embraced iteration and continuous improvement as normal engineering practice, creating equipment evolution that military procurement systems struggled to accommodate. The financial model supporting this innovation proved equally unconventional. LeTourneau invested company profits directly into research and development rather than maximizing shareholder returns. His factory operated with long-term perspective that accepted short-term losses during development phases, betting that successful equipment would generate profits through military contracts and post-war commercial sales. This patient capital approach resembled industrial manufacturing philosophy more than quarterly profit-focused defense contracting that dominated military procurement. His success demonstrated that civilian engineering thinking, when applied to military problems, could generate solutions that career officers trained in traditional doctrine would never imagine possible. The tree crusher's impact extended decades beyond World War II, but its underlying philosophy disappeared almost immediately. Post-war military procurement returned to conservative equipment selection that emphasized proven performance over innovative capability. The institutional preference for incremental improvements reasserted itself as defense contractors competed through cost reduction rather than revolutionary design. Modern military engineering faces challenges remarkably similar to 1943 Pacific jungle warfare, yet responses follow traditional patterns that LeTourneau's success should have permanently disrupted. Contemporary counterinsurgency operations in Afghanistan and Iraq required rapid terrain modification for forward operating base construction, route clearing, and perimeter establishment. Military engineers deployed equipment that represented incremental improvements to Vietnam-era designs rather than purpose-built machinery addressing current operational requirements. The contrast reveals institutional failure to absorb LeTourneau's core lesson. Military problems that appear to require more personnel actually need better engineering solutions. Modern defense procurement emphasizes multi-role equipment that performs adequately across various scenarios rather than specialized machinery optimized for specific challenges. This approach generates equipment that meets broad specifications while excelling at nothing, the exact opposite of LeTourneau's philosophy of purpose-built machinery that dominated particular problems. Financial pressures compound these institutional biases. Defense contractors optimize for profit margins through existing production lines rather than risky research into revolutionary equipment. Military procurement officers face career incentives that reward staying within established budgets and avoiding controversial equipment failures, making innovative proposals threatening rather than valuable. The systematic barriers that nearly prevented tree crusher development in 1943 remain embedded in contemporary defense acquisition. The engineering proof of specialized machinery's superiority remains mathematically demonstrable. LeTourneau's tree crushers cleared 30,000 Pacific jungle acres using 350 machines operated by 1,400 personnel. Equivalent manual clearing would have required 180,000 engineer battalion man-hours, roughly 22,000 personnel working full-time for 6 months. The 15-to-1 force multiplication advantage that specialized machinery provided changed Pacific War outcomes measurably. Yet modern military equipment procurement rarely achieves comparable innovation. Current defense budgets emphasize personnel costs, existing equipment maintenance, and incremental upgrades rather than revolutionary capability development. The institutional memory of how civilian machinists' absurd proposal transformed jungle warfare has faded into historical footnote rather than guiding procurement philosophy. Today, several tree crushers survive in military museums and private collections, monuments to engineering that military experts initially dismissed as impossible. They represent the 70-ton proof that institutional skepticism about revolutionary solutions often protects bureaucratic comfort rather than military effectiveness. LeTourneau's success came from seeing jungle terrain not as unchangeable obstacle, but as engineering problem requiring systematic mechanical solution. The question remains, if a self-taught California machinist could revolutionize Pacific jungle warfare against expert opposition in 1943, what other impossible military solutions are modern defense establishment dismissing because they challenge institutional assumptions about what contractors should propose and what military procurement should fund?